All right, we're going to look at this next lesson, Chapter 6, Lesson 11. We're dividing decimals by whole numbers. I'm going to guide you through our examples first, and then I want to come back to talk about this piece, about why we're not going to be using partial quotients today. So let's look at example 1. In example 1, we actually don't have to annex a 0 because the 0 is already in the hundredths place from the word problem. We're dividing $1.70 or 1 70 hundredths by 2. We're going to write this as a fraction because we're going to be using it in fraction form later on this week. This is what's so important about today is like we need to be using place value when we divide and when we talk about division. So it connects to the lesson from yesterday on modeling. So we're saying that two whole, like I can't divide one whole, $1, into two equal parts. Like I don't have enough ones to do that. So I need to regroup this one into tenths. So I'm going to regroup this one with the 7/10. So now I have 17 tenths, right? This sounds very similar to the work that our students did yesterday. I'm splitting 17 tenths into two groups. So that means that 8 tenths goes in each group. 8 times 2 is 16 tenths, right? 8 tenths times 2 is 16 tenths. When I subtract, I have 1/10 left over. What this means when I carry down the 0 is now I have 10 hundredths. And I know that's 10 hundredths because the 0 here is in the hundredths place. I'm dividing 10 hundredths into two groups. That means I have 5 hundredths in each group. 5 hundredths times 2 is 10 hundredths. When I subtract, I have 0. All right, so why we put this decimal point here in our answer is that it shows our wholes and our fractional parts or our decimal parts, right? So like anything behind the decimal is going to be tenths, hundredths, thousandths. Anything in front of the decimal point is going to be ones, tens, hundreds. So the decimal point shows where our wholes are and where our decimal parts are. Okay, again, like if you need to go back and listen to what I said here about place value, right? With the regrouping the one whole with the 7/10, so now I have 17 tenths. Like that is important for kids to be practicing, not just that this is the standard algorithm, but also connecting to the work that we did yesterday. Let's look at the next one. We're dividing 16 and 2/10 by 12. So in this case, we have a 2-digit divisor, which also our students will have to practice with today. In this case, 12 goes into 16. So I can take 12 ones here and I put 1 in each group. So 16 divided into 12 groups, I have 1 whole in each group. When I subtract, I have 4 wholes left over. I'm regrouping these 4 wholes in with my tenths, right? So now I have 2 tenths and 40 tenths, so now I have 42 tenths. When I split 42 tenths into 12 equal groups, 3 tenths are going to go in each group. I'm saying tenths because right here I'm in the tenths place, right? 3 tenths times 12 is 36 tenths. When I subtract, I have 6 tenths left over. Here I need to annex a 0. This will be the first time that students have seen annexing a 0 with our standard algorithm division, right? So when I annex a 0, what that actually means is I'm regrouping these 6 tenths into 60 hundredths. This is the work that we did yesterday. We regrouped 6 tenths as 60 hundredths. And now I know I can split 60 hundredths into 12 equal groups. That means that 5 hundredths go in each group. 5 hundredths times 12 is 60 hundredths. When I subtract, I get 0. I just want to put a side note right here. I often like to list my multiples here on the side so that students can easily have those ready for like them to use in this standard algorithm so that we don't have to keep flipping back between multiplication, division. So like a great practice would be listing your multiples first. Let's look at this next one. Here we actually need to annex 2 zeros, right? So we start with 1 9/10 and we're dividing it by 4. We're writing it as a fraction. I have 4 goes into 1 whole 0 times. I can't take that 1 whole and split it into 4 equal groups without regrouping. So I'm going to regroup that 1 whole as 10 tenths. So now I have 19 tenths, and I know that they're tenths because we're talking about the tenths place, right? 19 goes, if I split 19 tenths into 4 equal groups, 4 tenths would go in each group, which is why I have 4 tenths in my quotient. 4 tenths times 4 is 16 tenths. When I subtract, I have 3 tenths left over. Now I can't split 3 tenths evenly, so I need to regroup into 30 hundredths, right? And so because I put the 0 here, of course, because I annexed the 0, that means I'm now talking about hundredths. We'll do the same thing and realize, oh my gosh, I'm left with 2 hundredths left. I can't split 200ths evenly in between 4 groups without regrouping into thousands. Yeah, let's look at this last one. Here I'm taking 24 hundredths and I'm dividing it into 8 equal groups. What's different about this one is that I actually need to place that first number in my quotient. Often students will place it in the wrong, like this 3 will end up in the tenths place instead of in the hundredths place. So that's why I wanted to highlight this here. I can say like 0 divided into 8 groups is 0. I can't take 2 tenths and split it into 8 groups without regrouping that as a 20, right? 20 hundredths, so I'm taking this 2 tenths and I'm regrouping it with the 4 hundredths. So now I have 24 hundredths. Now I can split 24 hundredths into 8 groups evenly. That means 3 hundredths are in each group. And then I included this right pair share here so that students are practicing like when you need to and when you don't need to annex a 0.